What's up, YouTube? In today's video, we're going to be looking at debunking the using a string builder for string concatenation myth. Now, string building or string concatenation is fairly, but there's so many ways to do it in .NET. So I'm going to break this down into three primary categories, which is string building, string concatenation, and string mutation. Now, each of them is different, as you'll see when I show you the code, and I want to keep them sort of in different categories. And then for each of these three, there is two modalities. That is, are you doing this within a loop, or are you doing this without a loop or outside of a loop? And so through the course of this video, we're going to be looking at code. We're going to be looking at the IL, the intermediate language code that's been generated by the C# compiler. We're going to be looking at the internals of string immutability and what that means to us, and how we could either use it to our advantage or not by just knowing what it is exactly behind the scenes. Or I'm going to give you a sort of a mental model for that. And then we're going to be looking at string builder and some of the changes that have occurred since .NET 4.0. So there was a difference in string builders prior to .NET 4 and since .NET 4. And then we're also going to be looking at StringBuilder caches. All right, so there's a lot to cover, but this is going to be a fairly short video in that sense. I've got a lot of things pre-done. All the code's been written, all the benchmarking results are out. And so I'm just going to discuss some of those things and then some of the details of the string immutability itself. All right. So as you can see here, this is a simple concatenation concept. Now, within the concatenation, as I said, there are multiple ways to do concatenation. And in this method, I'm using the plus operator. So we can see here, we've got 6 different string variables defined. And then when we concatenate them, we are simply using the plus operator to produce the result. The next method that produces the same result, again, the same 6 independent or separate string variables defined here. And then we use the string.format to essentially concatenate the 6 strings into the one string. Maybe use the string.format method here to concatenate the string into the resulting string. The next way is again the same, 6 different or independent string variables defined, and we use string interpolation in this case to concatenate the strings. And finally, we use what I call string mutation. Again, as I said, for the purposes of this discussion, string concatenation has various modalities. You can do the string concatenation, you can use string mutation. So that's one. And then of course, string building, which is the third one. In this case, I'm essentially concatenating the string, but I'm using string mutation. And the reason I'm saying that is it's the same string variable that is being mutated in order to produce the final result. The results or the output of all of these methods is exactly the same. So it's how do you get there, right? It's not so much about what's happening. It's about how do you get there. Do you use the plus operator? Do you use the string.format method? Do you use string interpolation, or do you use string mutation, right? I've got the results of that here. So as you can see here, I've made the plus operator version of my string concatenation as the baseline. So the way this works is any number that's larger than the baseline is slower. Baseline being 1. So if it's less than 1, then it's faster. If it's more than 1, it is slower. So right away, you can see that the plus operator way of concatenating the string is the fastest way to concatenate strings. And the string.format method is the slowest, and by a long shot, right? The string concatenation with the string.format is almost 5 times slower than the plus operator. Over here, you can see the memory allocations, the total allocations, and you can also see the garbage collections, the Gen 0 garbage collection. This is per million operations. And again, in this case, the lower is better. And the same here, lower is better. So once again, you can see that the plus operator allocates the least amount of memory and also has the least number of Gen 0 garbage collections, while the string mutation method allocates the most memory and also has the most number of Gen 0 garbage collections. But in terms of the performance, the string mutation is not as bad as the string.format method. So right away, I'm guessing that the results here are already a bit perplexing or surprising because you don't expect certain things. You don't expect the string.format method to be so slow. And what the hell is the difference between the string concat versus, sorry, the string interpolation was the string.format method and the string mutation method. From having spoken to many .NET C# developers, they have a vague idea, if that, about what string mutation really is and why it's important for us to understand that. So we're also going to be looking at, as I said, the behind the scenes of what's going on in memory to give you a mental model of what string immutability means, what it is, and then what it means to us as C# developers. So first, we're going to be looking at the behind the scenes of the code that we have here in this application. So we're going to be looking at IL to understand what's going on. And then I'm going to make a few changes to this code and look at the IL again to see what changed in IL. So that'll give you a deeper understanding of the string interpolation as well as the string.concat method. All right. So let's look at the IL for this application. So I'm looking at the string.concat versus mutate method here of the class. And let's look at the plus operator implementation. So you can see we are allocating a few string literals here. So these are the 6 different string literals that we had. And then behind the scenes, it creates or defines a new array of string. Of course, this is not in our code, but it's happening behind the scenes. And then eventually, it calls the string.concat method, passing in the string array. So for those of you who've never seen the IL and never thought about what really happens with the plus operator, this is what's going on. Essentially, at compile time, the compiler looks at the code and says, okay, well, based on what I'm seeing here, I can simply use the string.concat method. And I'm going to show you later on that the string.concat method is super fast. It is just mind-blowingly fast. It's not even implemented in C#. It's implemented in C++. So it's sort of external. But there'll be a few more surprises here. So first of all, here you can see that in order to do the plus concatenation, the string literals are put into a string array, and then it simply passes that to the string.concat method. Okay, so then what's going on with the string.format method? We see the same thing with the string format to some extent. We got the literals being defined or allocated, and then we have a new array of object this time, not array of string. But then we end up calling the string.format method, passing in the object array as the data, and the actual string has already been defined over here for the string.format. Right? What about the string interpolation method? Again, we see the literals being allocated and defined. But now we're seeing again a string array, an array of string being defined here. And surprise, surprise, it calls the string.concat method with the string array as the argument. Essentially, the plus operator and the string interpolation method are, at least in this case, they are the same. But this is not to be seen like that. I'm going to make a change here to see what changes in this. I'm going to make a change in the C# code to show you what's going to change in the IL code here in a minute. But for now, as it is, both the code generated for the plus operator and this is practically the same. There's, of course, some extra allocations happening here for all of the spaces, as you can see. Right? It's not just the string literals that are being allocated. So this string array contains many more elements than just the literals. The string.mutate is, in many ways, the simplest looking string where it calls the string.concat method repeatedly. So, allocating the string concat returns the string, and then the next string is used for the next call, again, string.concat, and so on. So it's building up the string, if you will, or concatenating the string by mutating the same variable, right? The least amount of IL, but we know already from our benchmarks, is the slowest performing. Well, it's not the slowest, it's slow, but allocates the most memory. Like the string.format was the slowest. Okay, I'm going to now go into the interpolation method, make a little change, and we'll see the results. So just to recap here before we make the change, the string interpolation method allocates the literals, creates a new string array. Then it allocates a bunch of other string literals with the spaces, but eventually calls the string.concat method. All right, so now I'm going to make a change to the code here. So what I'm going to do now is just make a modification to this interpolation method here. So I'm going to essentially, this should actually be like that. Since I have the spaces in the data itself here. Okay, let's now comment out these. And do that. I've just essentially just reduced the number of strings being concatenated here. Rebuild that, and then go into the ILSpy once again and reload ILSpy the assembly. Go back to our string mutate. Look at the string interpolation method here. And now what you're going to see is it is allocating the literals here, but then it simply calls the string.concat, no array being defined, and the string concat with the 4 arguments. So this is the magic of the string interpolation. Behind the scenes, at compile time, it could either result in IL that continues to that uses the string.format. Sorry, we didn't see the string.format version. It uses the string.concat method with the array, or simply calling a string.concat method overload that takes 4 arguments, as you can see there. The string interpolation method is a little more, it's smarter, right? Because at compile time, it's doing a few things. If you're not effectively using formatting of a string, and that's one of the reasons that the string.format method is way, way slower. It's built for much more than just simple concatenation. And if you want to format date times, if you want to format numbers, if you want to format, I don't know, whatever else to format, the formatting is going to be expensive. So if you're not going to use or don't need the actual format capability, don't use string.format. However, now we have string interpolation. So what I would recommend is if you want to concatenate strings, you can use the string interpolation method because it is to some extent resulting in the same code that the plus operator results in, even though the plus operator is faster. The string interpolation gives us an advantage where at compile time, it decides whether it should be using the string concat with the array. Should be using the string concat as the overload for 4 arguments, because the string concat has 4 overloads, or at least with arguments up to 4 arguments as overloads. Or should it use the string.format method behind the scenes? The string interpolation implementation, or the code resulting with the string interpolation, could result in one of these 3 different ways: the string concat with the array, the string concat with the method call, and the string.format. It's going to decide that at compile time as to which one it should be using behind the scenes. So the string interpolation method is probably the smartest, safest way to do it. But as we can see, the plus operator is the fastest, and the plus operator has the least memory allocation and the least number of garbage collections as well. So even though the string interpolation is a nice method, is a smart feature that we have in C#, the plus operator might still be, it's a little more performant in those situations where you need that extra boost. The string.format method should be used where you need actual formatting capability. So you can still use the string interpolation feature, because that could result in behind the scenes using the string.format method, because it's going to look at compile time and to see what it is you're doing and choose whether it should be using the string.format method or the concat with the array or the concat method with the separate arguments, right? The mutation is something you should not do. So I think string mutation, that is taking the same string variable and mutating it a number of times, even though it's possible and you get the same result, is not a good choice. It's never actually a good choice unless it's like 2 strings, right? S1 is equal to this and S1 plus equals that, and then you're done. You may be able to justify that. Now I'm going to be showing you behind the scenes what actually string immutability means and how it impacts us, or what it means to us as C# developers. So you have this mental model. All right, so let's take a look at that. All right, so you can see here, now imagine this to be the garbage, the heap where all the memories are being allocated, and we've defined a string called hello, and that is the memory representation of hello in the heap. So we have a string variable allocated in memory, and the value is hello. And I want to now mutate this string. So I want to say plus equals world space world. So what has to happen and what is actually going on under the hood? Strings are immutable in C#.NET. Are they? Maybe not. We'll look at that later on in this episode. But for now, strings are immutable. What does it mean? It means you can't mutate, you can't change a string. Even though we can write the code that seemingly allows us to do that, it's not actually doing what you think it's doing, right? So this is what really happens. I've got the string hello defined, and I want to now add to that space world. So first of all, because strings are immutable, it can't modify the string. So it's going to have to allocate a whole nother string. But this allocation has to include or have the capacity to include the space world as well in it. So what happens is it then allocates this new memory with the extra space in here. Then it has to copy the data from here to here, the pre-existing data from here to here. Right? So it has to do that. And this copy is not cheap. It is expensive. So even though allocations in C# are cheap, by cheap I mean time cost, right? Cheap, not in terms of memory. Memory, of course, the cost is the same. But how much time does it take to allocate extra memory in C#? It's almost negligible. You can see it as that. Garbage collection is where we pay the price. Right? So the more memory we allocate, the more garbage has to be collected. And it's eventually going to come and bite us. But the copy is even more expensive, or it's also expensive. Copying data from one memory location to another memory location, as we did here, is expensive. Keep this in mind. Copy is expensive. And then it'll take in the world and put that here, right? Now, at some point, if you just did this once, then at some point, eventually, this string, the previous string variable that is still in memory somewhere, has to be garbage collected. If you do this mutation repeatedly, you're producing a lot of garbage that needs to be collected, right? But let's look at the other option. We had multiple strings defined, and we concatenated them with the plus operator to get our result. So the number of strings allocated is the same, right? Because you're not changing the data, so it's the same allocations. And your result is the one you want. So eventually let's say the 5 strings that made up your result have to be garbage collected. So no matter how you dice it, the garbage that you create is the same. The memory allocated is the same. The difference between the plus operator's performance and the mutate string performance is the copy. So the copy is expensive, which is why I said mutating a string is almost never a good option. But using the plus operator is not a problem, right? So for example, I've seen code where the two string methods being implemented in a object. Let's say this object has 20 properties. So because people have been told, when you're concatenating strings, you should always use a string builder. In the two strings implementation, what they're doing is they've got all the properties and they want to take the values of those properties and put them into a string of some form. They're using the string builder there. Now, so far, we haven't even talked about the string builder, right? We're just simply looking at plus and format and interpolation and mutation. What I'm trying to one myth I'm trying to debunk here is you don't use the string builder when the string.concat method, or indirectly, meaning you write your regular C# code with the plus operator or the interpolation operator, and the result is way better than the string builder. Now, I realize we haven't seen the string builder or talked about the string builder yet. But for now, don't use string builder if what you're simply doing is concatenating a string. You're taking multiple strings like property values of a DTO object to produce a 2-string result. No need to use a string builder. So when you're concatenating a string that's not in a loop, don't mutate, but use a plus operator or maybe even the string interpolation operator. Those are the two options you should be using, or features or methods you should be using. Because we know that behind the scenes, it's eventually using string.concat, both of them. So if you want to use string.concat directly, that's fine. But I think from a readability standpoint, people will be using the plus operator or the string interpolation is much more readable, right? So now we're going to be moving on to building a string. By the reason I'm saying building a string, because that's in a loop. It's not a one-time operation, right? We say use a plus operator to get the result. What if we have to do this repeatedly? Not necessarily in a one method. Let's say the same method that we have where we are concatenating a string using the plus operator, or the toString method of a object, DTO object that has all these properties that you want to put into a string and produce a result. What if that method was called thousands of times in your application? What should you be doing? Well, you're not building a string, you're still concatenating a string. So you're still better off using the plus operator. Now, of course, if that's happening, a million times a second, you might want to rethink your strategy a little bit. But, depending on whether other property values changing, is this the same string value coming over and over? Maybe you can do some caching, right? If the property values have not been changed, then why keep rebuilding a whole other string each time? Concatenate the values once, cache it, and then reuse the same values. So that's a little more complicated to discuss here. So I'm going to discuss the details of that. But I would say for concatenation purposes, simply use the plus operator or the string interpolation, and that's it. End of story. We're not doing this in a loop. String building now is sort of the looping version of it. You're building up a string. Now, how do you build up the string? You can do the same thing. You can mutate the same string over and over in a loop, and you can build up the string. You can use the plus operator. You can use the string interpolation operator, or you can use the string builder, because you're building the string. So every loop is not the result you want. It's by the time the loop is finished, you want that result, right? But you can do that with mutation, concatenation, or string building. So let's look at an application where I use that and I have a benchmark, the results of that as well. In fact, let's open up the benchmark for that first. Okay, so here I have various different ways in which we are concatenating or building up a string. The plus operator is for concatenation. It's not in a loop. The plus operator loop is doing the building, so that's in a loop. So this is the plus operator outside of a loop or not in a loop, and this is using the same plus operator but now in a loop. Then we have the concat method, not in a loop, and the concat method in a loop. Then we have the string builder outside of a loop and a string builder in a loop. And I have another method here called the string builder loop cached. We'll discuss that a bit later, but essentially the string.join is again without a loop. So I said there are sort of these two modalities, the in a loop and outside of a loop. So let's discuss the outside the loop versions first. So you can see here in the graph that these three here, the green, the brown, and the orange. So that's the green is the string.join. The string.join, the green. The brown is the plus operator. That's this one here. And the orange is the concat method. Now these are neck and neck, right? The concat method is the fastest because the plus operator uses the concat method under the hood anyways. And the string.join was actually a surprise to me. I didn't realize that the string.join is so fast. So it's doing some similar magic behind the scenes. But for concatenation purposes, again, you can use the plus operator or the string interpolation operator if it's a bit of complexity there. We have to add spaces and things in between the values that you're trying to concatenate. But the concat is the fastest for non-loop building of a string, right? Now let's look at the looped version. Oh, the string builder, if you will. For example, here, just look at the string builder. This yellow is the string builder that's not a loop. The blue is the string builder in a loop. So if you're concatenating a string using a string builder, the yellow is here. So these are the other three, and this is the yellow. Of course, I didn't explain the horizontal is the number of strings being concatenated, the x-axis, and the y-axis is the time in nanoseconds. You can see the string builder outside of a loop is quite a bit slower than the concat, the plus, and the string.join methods. So what do you get from this? Using a string builder, and you're not seeing the memory allocated. Let's look at the memory allocated also. So in the memory allocation, the Gen 0 allocations and the memory allocations here is for 10 strings that are being concatenated in some fashion. If you look at the string builder, it has 0.7 Gen 0 collections and 3072 bytes of allocations. You can see here that this has got the most, but this one, concat loop, has got the most allocations. But the plus operator has only 1136 bytes that are being allocated. And if you look at the string.concat method, which is here, it's got 1032 bytes allocated, right? And the least number of Gen 0 collections as well. So for simple concatenation, the concat method is by far the fastest, so the plus operator is faster than StringBuilder. So don't use StringBuilder for simple concatenation. We can see that here, that is quite a bit slower and also allocates more memory and has many more Gen 0 collections. So it's not a good idea to use a StringBuilder for simple concatenation requirements. However, for string building, the story changes a little bit. Now, if we look at these two, the sort of darkish blue and the gray, which is the plus operator in a loop, so plus operator loop, and the gray is the concat in a loop. So the plus operator in the concat, which is these two lines going up here, this is like a linear growth, if you will. As the number of strings increases, this time is increasing linearly. They're a bad idea. Right? So if you're building a string in a loop, the same two methods, the plus and the concat, which were fast for the one-off, is not the best choice for building strings in a loop. And then the string builder loop, where here, so there's a string builder, which is the yellow, but there's a string builder loop, which is the another shade of blue here, which is these two. The string builder with or without a loop makes no difference virtually. Like these two lines are the string builder in a loop and string builder outside of a loop. They're sort of the same. So the string builder is the best one to use if you're repeatedly concatenating or building up a string. So the result of the loop is the final result you want of your string. So you're building up the string after iterating over something multiple times, right? So use the string builder only for those situations where you're building up a string in a loop. If you're building up a string by concatenation as a one-off thing, don't use the string builder, just use the plus or the string interpolation method. All right. Now, we talked briefly about when I sort of gave you a hint that the strings are not mutable in C#. It turns out that the string class actually is not immutable, it is mutable. The difference is that we as C# developers don't have access to these methods from the outside, as in those methods are available, they're internal methods, so they're available within the assembly, but not outside of the assembly in which the string class is defined. But the string builder is a class that's in the same assembly as the string class. So the string builder actually has access to the internals of the string class. And it turns out that in .NET prior to .NET 4, the string builder was essentially using that feature of strings actually being mutable. So it would manage a buffer and mutate that string over and over to build up a string. And it was a bit more complicated than that, but basically it was using the features or the capability of the string being mutable. In .NET 4, that changed. In .NET 4, they changed the strategy quite a bit. They started building up let me show you, I've got a PowerPoint slide here. So let's take a look at that. Right. So the string builder would allocate chunks at a time. So this is not just one sort of, it's in array, it's a chunk of characters at a time. The chunk size could go up to a maximum of 8,000, 8K chunks. The chunk size is about 8K. And there's a reason for that. Basically, essentially, they're trying to find the best size, which is not too small, but it's not too big. Because imagine if you had a string where you weren't actually allocating up to 8K, you just needed 400 bytes. You've allocated 8K just to concatenate 400 bytes, right? So that's not the best use of memory. So they had to come to a sort of a size-wise, what's the best size, which is not too expensive, as in memory-wise too expensive, and it's not too little, such that every time you want to keep growing the string, you have to keep allocating newer chunks. They're also trying to keep the each chunk out of the large object heap. And the large object heap has anything that's above 85K in size will go into the large object heap automatically. So they were trying to ensure that each chunk that's been allocated is not going to end up in the large object heap. That's going to make it more expensive to garbage collect. The chunks are in a sort of a linked list manner, right? The previous chunk has a pointer to the next chunk. So the way it works is it first will allocate the one chunk, and you're building up your string. Let's say in a loop, you're building, and eventually at some point it's running out of memory. At that point, it's going to allocate another chunk and then hold a pointer from this chunk to this chunk, so it knows where this is, and continue on building up the string. And when it runs out of memory again, it'll allocate another chunk, point from here to there, and keep going like that. When you call the toString method on your string builder, at that point, it has to kind of do this pointer chasing to construct a string by chasing the pointer from here to here, and then here to here, and here to here, and eventually give you a new string instance by chasing the pointers to produce the final string. So this string builder, the .NET 4.0 version of the string builder, is quite a bit more efficient, if you will. There are pluses and minuses. If you were to do a benchmark between the older version of string builder and the new version, there are some differences in performance, but the reason they did this here in .NET 4 onwards is the building, when it goes beyond a certain size, this is quite a bit more efficient than the previous version of string builder. The recommendation in .NET is if you're using a string builder to concatenate a string over and over again, let's say you're building up with the string, but whatever method that is being called a million times a second, then maybe you should be caching the string builder itself and then clearing out the string builder before you start doing the concatenation each time. So you're not having to reallocate all these chunks over and over, right? Because once these chunks are created, they're there. So at that point, maybe you should just leave the chunks alone. In the C# source or reference source, there is a StringBuilderCache class. And it's unfortunately not available to us directly, but the source code is there, so we can go and copy paste it and put it into our own system, and we got the StringBuilderCache available to us now. Right? So that's what I've done. So I'll show you the benchmark for that as well. This is in the same Excel spreadsheet here. So as you can see here, we have the string builder loop cache. In other words, it's the string builder, a cached string builder, but in a loop, right? So the color for that, string builder cache loop is this really, looks like almost black, blue, dark blue line here. And you can see the string builder looped version, these two being the string builder version, the looped and the unlooped one, these two lines. This is the cached version. So it is a bit faster than the plain old string builder. It's not as slow as these two. If you look at the memory allocations, so these three lines, it has about the same number of Gen 0 allocations and just a little bit less memory allocation than the string builder. Now you should look at the code here. I did find that I had to do some magic here to get this to actually work. So if I look at my implementation for the StringBuilderCache, this is that one. When I acquired the string builder, the cached version, I'm saying I want it to be so large, as in the pre-allocate or the capacity should be so much, which is the number of strings that I have times the string length times 2, because of course in C#, a string is a UTF-16 string. It's not a ASCII string, and it's not a UTF-8 string, right? So you have to account for the fact that it's a UTF-16 string. And because so this is, if you don't allocate, if you don't do this up ahead, then there's virtually no difference between the string builder and the string builder cached. So the lesson here is use a string builder if you're building up a string. Now, if you're doing this often, million times a second, million times a minute, then maybe you should be using a cached version, right? And if you don't have a cached version, then go get it from the reference source. I'll put a link in the description below, where you can go find the reference source for the string.cached version of the string class, and you can use that. So string immutable, or mutating a string, is never a good idea, right? So that's certainly something you don't want to be doing. the plus operator or the interpolation method are perfect for concatenating strings. If you're building a string in a loop, the string builder is the right choice. So the myth that you must use a string builder or should use a string builder when you're concatenating strings has been busted. That's not to say never use a string builder. There are specific cases in which to use a string builder. And then there are specific cases to use the plus operator or the concat method or the string interpolation method. And of course, the string join to me was the big surprise. I just thought, how good can this be? And it's actually keeping up with the plus operator and the concat method. So they're almost as good, right? All right. So I hope you've enjoyed this video. I hope you learned something new. And as usual, if you did, please give me a thumbs up. If you haven't subscribed and you reached so far, please subscribe. And I will see you next time.